Hello and welcome dear students. Today we are going to discuss diesel engine. So far we learned Carnot engine, its efficiency, then auto engine and its efficiency. Okay. And the third one is the diesel engine, or it is also called as diesel cycle. So here is the name. And the first point in case of diesel engine is Rudolf Diesel, a German engineer who developed a heat engine or cycle where the ignition takes place by compressing the working substance. Okay, where ignition, that is combustion of the working substance, takes place by compressing the working substance. Okay, so here is the basic difference in case of diesel engine as compared to other auto engine and Carnot engine. Second point is diesel engine is an internal combustion five-stroke engine. Okay, five-stroke engine where crude oil supplies the fuel. It consists of the cylinder and piston. The cylinder is more robust than auto engine since it has to withstand maximum pressure. The cylinder is provided with inlet valve for air, another inlet for spraying crude oil at right movement, and exhaust valves. The opening and closing of these valves are controlled by the motion of the piston. Okay. After that, third point is working of diesel cycle. The working is illustrated in the next figure, of course, slide. There are five strokes in a complete cycle as shown. So the first one at the bottom of this diagram, you can observe the first stroke, okay? And just observe the motion of the arrow indicating the motion of this rod, fulcrum, and the shaft, okay? Which is connected to the piston. So from bottom, first part of this diesel cycle is the piston as shown in this diagram, this one. Then cylinder as shown in this diagram. Then third one, inlet for air. So this is the inlet for air as indicated by the diagram. Then inlet valve opens. So in first stage of this cycle, inlet valve opens, okay, which is for air. At the center of the cylinder, we can see oil injector valve. And after that, at right hand side of the cylinder, that is after oil injector valve, we can see exhaust valves, which is closed. Okay. So we have piston, cylinder, inlet valve for air, oil injector valve, and last one is the exhaust valve. Inlet for air and inlet valve are open in first stage, whereas the exhaust valve is closed. Okay, so just note down and remember the things which are there in first stage. So in second stage, after completion of first stage, second stage, observe the motion of this arrow, and due to which observe the motion of this rod, connecting rods and the piston. Okay, so here in second stage, all valves, that is inlet valve and exhaust valve, both valves are closed. After that, observe the position of connecting rod, crankshaft, etc., and the piston in third stage, which is followed by the completion of second stage. In third stage, only oil injector valve is open. So here in this diagram, oil injector valve is spraying oil inside the chamber. Okay. So also observe the position of piston in second and in third case also. That is stage also. Okay. After that, in fourth cycle or fourth stage, once again observe the motion of the connecting rods and the piston. Then in this case also all valves, that is inlet valve and the outlet valve, I shall write over here I for inlet and O for outlet. Both valves are closed. Now, after that, fifth stage. Now here also observe the direction of motion of this arrow along with the motion of connecting rods. Now observe the piston and the arrows inside the cylinder. Okay. So in this case, in this fifth stage or last stage of the diesel cycle, this inlet valve, that is I, inlet valve is closed, only exhaust valve is open. Okay. And which releases or removes useless gases. So here is an opening for removal of useless gases. Okay, so this is the main function of the exhaust valve, which is opened in last stage. Okay, so after that we shall see process. The first one, the first stage is the suction stroke. Okay, if you remember, this is the first stage. Okay, so the first one, this one, first one is the suction stroke. In this stroke, air valve is opened, air valve is open, that is inlet valve, and air is sucked into the cylinder at constant pressure. It is represented by EA on indicator diagram, which we shall see in the next slide after this discussion. Then the second one is the compression stroke. In this stroke, all valves are closed, okay, and the air is compressed to about 1/17 of its original volume by the backward motion of the piston. So the temperature rises about 1000 degrees Celsius with large pressure. This operation is shown by AB on indicator diagram. So 1/17 means, suppose initially 100 cc, that is 100 cubic centimeter, is the volume of air which is sucked inside the cylinder during suction stroke. Okay, so if initially 100 cc volume is there, volume of air is there, that is compressed to 100 divided by 17. So roughly it is equal to 5.86 cubic centimeter. Okay, so just imagine that 100 cc of air is compressed to become around 6 cc. Okay, so this is compression stroke, and due to this compression, the temperature of the air inside this cylinder rises to 1000 degrees Celsius, and hence large pressure is acquired by the air inside the cylinder. Okay, now under this condition of second stroke, that is the compression stroke, third stage operates, and the third stage is the injection of oil inside the bracket constant pressure stroke, that is the pressure of the second stroke remaining constant. Oil is getting sprayed inside the cylinder. Okay, so at the end of the compression stroke, that is at the completion of second stroke, the oil injector valve is opened and oil is sprayed into the cylinder. So due to high temperature, the oil burns spontaneously. Okay, the pressure is maintained to be constant by regulating oil supply, and the piston moves forward. So it is called as constant pressure stroke. After that, this is represented by BC on the indicator diagram. So here temperature, due to burning of the spontaneous burning of the oil along with the air, the temperature rises to about 2000 degrees Celsius. Okay, somewhere you can find 2500 degrees Celsius. It depends on the quality and type of the engine. Okay, The fourth one is the working stroke. In this stroke, all the valves are closed and the gas mixture is allowed to expand adiabatically by forward motion of the piston. This is shown by curve CD on the indicator diagram. At D, exhaust valve is opened and the pressure drops to A. Of course, these are the things on the indicator diagram. Okay. And the last one, don't worry, we shall discuss the indicator diagram in the next slide. The exhaust stroke, the last one, the fifth one is the exhaust stroke. In this stroke, the useless mixture of gas is thrown out by opening exhaust valve. Okay, this is represented by AE. After this stroke, a new cycle begins. That is once again suction stroke, first one, then second one compression stroke, then third one injection of oil at constant pressure, then again the working stroke, the exhaust stroke, etc. Once again, suction stroke, compression stroke, injection of oil, then working stroke and the exhaust stroke. Okay, so we shall watch this video, YouTube video, of course, that how diesel engine works. Okay, and further we shall discuss the next things of the diesel engine. So please be with us.
Transforms the chemical energy in fuel to mechanical energy. An internal combustion engine transforms the chemical energy in fuel to mechanical energy. Diesel engines, which have been serving mankind for over a century, are the most versatile and economical IC engines. To release the chemical energy in diesel effectively, an atomized form of the fuel is made to contact with high temperature and high pressure air. This energy is effectively transferred as mechanical rotational energy. So the operation of a diesel engine is all about producing high temperature and high pressure air continuously. We will see how this is achieved in this video. Piston, connecting rod, crank, and cylinder form a mechanism called slider crank mechanism. Here, the linear motion of the piston is transformed to a rotary motion at the crank. In an IC engine, this mechanism is properly supported in an engine block. Cylinder head, valves, and fuel injector are fitted above the engine block. When the piston moves downwards, inlet valves open and fresh air from outside is sucked in, or, in other words, the engine breathes. During the return stroke, inlet and exhaust valves are closed, and the air inside the cylinder gets compressed. During the compression stroke, the piston does work on the air, so the temperature and pressure of the air will rise to a level which is higher than the self-ignition value of the diesel. An atomized form of diesel is injected into this compressed air. The fuel gets evaporated and undergoes an uncontrolled spontaneous explosion. As a result, the pressure and temperature rise to high-level values. The high-energy fluid pushes the piston downward. The hot air does work on the piston, and energy in the fluid is converted to the mechanical energy of the piston. This is the only stroke where the piston absorbs power from the fluid. Due to inertia of the system, the piston moves upwards again. This time, the exhaust valves open and the exhaust is rejected. Again, the suction stroke happens. This cycle, which has a total 4 strokes, is repeated over and over for continuous power production. You may have noticed that a bowl is provided on top of the diesel engine piston. During the compression stroke, this bowl helps produce air that is rapidly swirling. Thus, the injected fuel gets mixed with the air effectively. The mechanical design of IC engines, particularly that of diesel engines, is a challenging and interesting task. Since the combustion process in diesel engines is never uniform and smooth, they are prone to more vibration and noise compared to petrol engines. Thus, diesel engines require a rugged structural design. Out of the 4 strokes, it is only during the power stroke that a tremendous amount of force is exerted on the piston. So a single cylinder engine will always have high force non-uniformity as shown. Similarly, the output power will also have a fluctuating nature. But with more number of cylinders, one can overcome these problems. Consider this 4-cylinder engine. Here, 4 different strokes can occur at a time. So the power stroke is always present in the engine. As a result, a 4-cylinder engine will have better force and power uniformity. In short, the more cylinders an engine has, the smoother it will operate. A 4-cylinder engine generally operates on the following firing order. A heavy flywheel, which acts like a power reservoir, further helps in smoothing out non-uniformity of power. A huge unbalanced force arises in the form of dynamic unbalance due to the excessive mass at the connecting rod side. This is negated by providing counterweights on the crank side. Opening and closing of valves are accurately controlled by a pair of camshafts. Camshafts derive motion from the engine. It is clear that the camshafts need to rotate at half the speed of crankshaft. We hope you had a nice introduction on the working of diesel engines. Thank you.
So, okay. Watch this video again and again so that you will understand how the diesel engine works. Okay, it has covered many points. So this is the YouTube link. So after that, as I told you earlier, we have indicator diagram for the diesel cycle. Okay, on the y-axis we have plotted pressure, and on the x-axis we have plotted volume. So here the cycle starts from E A, then B, C, D, and A, again E. Okay, so we shall start from the E, where P0 is indicated, that is original pressure, and this arrow is indicating that the cycle is going from E to A. Okay, so again from A to B. So A to B is the adiabatic compression. Okay, and E to A is also called as the suction stroke, or it is also called as a charging stroke or intake stroke, as discussed in the earlier engines. Okay, so E to A is the suction stroke, A to B is the adiabatic compression stroke, B to C here is the fuel injection and combustion stroke is there, which is also known as constant pressure stroke. Okay. So here B to C, the pressure of the working substance remains constant. Then C to D is the power stroke. Okay. And D to A is the exhaust stroke as indicated by the blue arrow. And here Q2 is written in front of the blue arrow. And here between B to C, Q1 is written and it is indicated by red arrow. There is a meaning. Red arrow means intake of heat. Okay. And here rejection of heat. In case of blue arrow, Q2 means rejection of heat. So if we extrapolate point D and point A, we shall meet another point that is F, and we can calculate the efficiency of diesel engine with the help of this F point. So to calculate efficiency of diesel engine, we need to be temperatures to be discussed on the diesel cycle. Okay, so here T1 is the initial temperature, which is E to A, so which remains constant. So we have denoted T1 over here, then T2 at B, then T3 at C. Of course, you know very well that due to this adiabatic compression, whatever temperature of air is there, that is T1. Due to compression, that is adiabatic compression, temperature rises to 1000 degrees Celsius, which is T2. Okay, so here I shall write 1K. You know very well that K stands for 1000. Therefore, the temperature over here is 1000 degrees Celsius. Okay, K stands for 1000. It is not Kelvin. Note that it is not Kelvin. So to remove your doubts, I shall write 1000 degrees Celsius is the temperature. Okay, that is the T2. Then T3, due to combustion, it rises to 2000 degrees Celsius, or depending upon type of engine, it may rise to 2500 degrees Celsius. After that, power stroke, temperature decreases to initial temperature. Okay, so here another point, that is another temperature at F, which is T4. So we need T1, then T2, then T3 and T4 for the calculation of efficiency of diesel cycle. Okay, so here this is the indicator diagram, and you have to remember how the arrows are going. So E to A is the intake or suction stroke, so arrow is going along this way. Then A to B, this is the arrow, so cycle is going along this way. Then B to C along this way, then C to D along this way, then D to A along this way, and then exhaust stroke A to E. Okay, so this is indicator diagram. Also, during examination, you have to mention V1, V2, and V3 denoted by dotted lines. So, okay, we shall stop over here and we shall discuss the next point, that is efficiency of diesel cycle, in the next lecture.